All right, hey, what's up? It's your old pal, Mr. Cook, and we're gonna keep going through this extra review. We got through the two lengthy parts, Gauss-Jordan elimination, where it's like kind of tough also and lengthy, and then this one where it's just tedious work for multiplication. Okay, next up we have to solve for x, y, and z, given that a is equal to b. If a is equal to b, then that means that each individual corresponding term should be the same. Like notice that I've got a one here, and then the same spot in the other matrix, a one, a three here, and a three here. They're all going to be the same. So you can just kind of make some equations out of these, like x plus y equals 4, and then 2 is equal to x minus y. And then finally, well, geez, that's a really easy one. Z equals 2. All right, well, I mean, I've already got one of the solutions for Z. I mean, one of the solutions for one of the variables Z right here. And the other one, I just have a system of equations. And I can solve this real easily by just using elimination. Like, did you notice what you can do real easily? Just add the two equations together because you have a positive y and a negative y. And remember, they just cancel out. So that's what I'll do. X plus y equals 4. I'm going to add that onto x minus y equals 2. Okay, so if I combine like terms, x and x gives me 2x, y minus y is nothing, and then 4 and 2 gives me 6. So if I divide both sides by 2, I get x equals 3. And then if I pick either of these equations, I'd probably pick that one, x plus y equals 4. If I let x be equal to 3, so 3 goes in there, that means that y, if I subtract 3 from both sides, y is going to be equal to 1. So that's all of the solutions for the different variables. And you can plug them back in and, it should work out. Like this x plus y right here should be 4. And sure enough, if I add 3 and 1 together, I get 4. It should work out. Okay, 4. Let a be equal to that and b be equal to that. Find c if a plus 3c is equal to 2b. Well, okay, that's not that bad. You can just use it as an algebraic expression. If I want to get c by itself, then what I would do is I'd subtract a from both sides. So 3c is equal to 2b minus a. And then what you can do is divide everything by 3. So c will be equal to 2/3 b minus 1/3 a. That is if you're comfortable using fractions, you can do that. If you're not, you can just leave it like this. And then whatever you get when you add this stuff together, just divide every single term by 3, to get C all by itself. That's probably what I'd, end up doing just for simplification purposes. So yeah, let's write it up like that. So 2b minus a, that's the first thing I got to find because that's what 3c is equal to. So let's find this part first. So if I take 2 of b, so 2 times b, negative 2, negative 1, 0, 3. And then if I subtract away 1 of a, which is 2, negative 1, negative 3, and 4, what do I get? Well, if I distribute the 2 into all this stuff, then I get negative 4, 0, and then negative 2 and 6. Then if I subtract away the other matrix, here's what I get. So let's see, negative 4 minus 2 would be a negative 6. 0 minus a negative 1 would be a positive 1. And then negative 2 minus a negative 3, so plus 3 would be positive 1. And then 6 minus 4 would give me 2. So that is equal to 3 C's. So if I just divide all the terms by 3, that would give me C. So I'm going to do that, divide everything by 3. So I get negative 6 over 3, which is negative 2. And then 1 over 3. And then 1 over 3 again. And then 2 over 3. So there you go. That's the solution for this one. All right, next up. Letter A for number 5. Find the determinant of each matrix. Okay, so with a 2 by 2 case, which is both of these, there's a real simple way to find the determinant. All you gotta do is just take the this one and this one, multiply them together. So negative 2 times 4, and then subtract away these two multiplied together, which is just 0. So negative 2 times 4 is negative 8. So negative 8 would be my determinant of this matrix. All right, and then the other one, let's see, 4 times 0 is 0. And then negative 2 times 0 is also 0. So I just get 0. All right, and then for part C, it kind of depends. You might have learned a shortcut for this, but I'm just going to use the cofactor method for finding the determinant of a 3 by 3. So all you gotta do is just pick like one matrix row or column to expand on. So I'll just like pick the first row. And those numbers that I get, the -1, the -2, and then the 5 are gonna become cofactors on a determinant algorithm that I'm gonna put together. Here's how it goes. This is equal to, it'd be -1, and then times the determinant of something. And I'll get that something in a little bit. And then -2, and then I'm going to take that -2 and multiply by -1 because it goes like in a pattern. Like you have these numerical multipliers that go into the determinant for each of these. So like it's going to be a +1, and then a negative, and then a positive, and then negative, and then positive. It just goes in this order over and over again for the sign multiplier. So that's why I put a negative on there. And then 5, so times some determinant, and then plus 5 times some determinant. Okay, and the way that I find the determinant for those is by taking, each of these numbers, -1, and then like canceling out the row and the column that it belongs to. And the remaining matrix, that 2 by 2, I do its determinant. And then I do the same thing with the -2. So if I circle the -2 and get rid of the column and the row that it's attached to, then I have 1 and 3, and then 4 and 1. Those are the columns here. And then the last one, take the 5, get rid of its column and its row, and I have 1, 1, 3, 3. All right. And then I just do the algebra for all this stuff, and that gives me my determinant. So I have -1 times, and then the determinant of a 2 by 2, I multiply the diagonals together. So 1, and then subtract away the other diagonals. So 12. And then plus 2 now, because the negative times the negative is a positive. And then this determinant, 1 times 1 is 1, minus 3 times 4 is 12. And then plus, now it'll be 5 times parentheses, and then it'll be 1 times 3, so 3, minus 3 times 1, which is also 3. Okay, so almost done. 1 minus 12 is -11. 1 minus 12 is -11. 3 minus 3 is 0. So this just becomes 0. So I can get rid of that. And then let's see, distributing in, I get a +11. And then a -22. So 11 minus 22 is going to be -11. So there's my determinant for my 3 by 3. Okay, next up, use Cramer's rule to solve. So Cramer's rule is pretty easy. Let's solve for x first. X is going to be equal to, so it'll be the determinant of the coefficient matrix. So that'd be 5, 6, 4, -6 in the denominator. And then in the numerator, I do the exact same matrix, 5, 6, 4, -6. But you know how like we're solving for x? So we take the x column and we replace it with the b value, the solution values, 3 and -9. Okay, and then we just do the determinants and then simplify, and we've got our x variable. So the determinants would be 3 times -6, so that's -18. And then minus -9 times 6, so minus -9 times 6 is -54. And then in the denominator, 5 times -6, -30, minus, and then it'd be 4 times 6, which is 24. All right, so let's see what we end up getting here. -18 plus 54 would be, 36. And then wait, did I do that right? -30. Yeah, gosh, okay. -30 minus 24 is a -54. So that reduces down to, let's see, those are both divisible by 9. So wait, is it more than that? 18? Yeah, they're both divisible by 18, so that'd be a negative 2/3. And then using Kramer's rule to solve for the y value, I would get the same thing. So like I write out the determinant of the coefficient matrix in the denominator. So that'd be 5, 6, 4, -6. And then in the numerator, I write the same exact thing, 5, 4, 6, -6. But then when I have that like the y values here, I replace those with the solution values, which would be 3 and -9. Okay, so finding the determinant for the bottom part, that's going to be the same as the bottom part in the previous problem. So that'd be -54. And then in the top part, let's see here. So that'd be 5 times -9, which is -45. And then minus 4 times 3, which is 12. So that's a -57 or -54. That seems a bit off. Let me double check that I wrote everything down right. 3 -9, 6 -6. Well, those are both divisible by 3. So what does that give me? That'd be like 19 over 18. Jeez, is that really what it's going to be? I got to double check. Just give me a second. If you want to fast forward a minute, you can. I just want to double check that I got everything correct. 3 -9, 6 -6. 3 times -6, -18. And then 6 times 9 is 54. And then it's adding. So it'd be a positive 36, right? Yeah. And then 30, -30, minus 24, -54. Yeah, I think that's right. Wow, that's kind of weird. Well, I don't know. I can always double check. I'll just check one of the problems. Like 5x plus 6y equals 3. Let's verify that that's true. So 5 times x, which is -2/3. And then plus 6 times y. So 6 times, geez, we could have used easier numbers, 19 and 18. Golly. Well, let's see here. 5 times -2 is -10. So -10 over 3 plus, and then let's see here, the 6 and the 18, those both divide by 6. So that'd be 18 or 19 over 3. So that'd be a positive 9 over 3. Yeah, that is 3. Jeez, those are the answers. Man, that sucks. Okay, well, those are the answers. That's x and then also y, and a pretty easy way to get it through Kramer's rule. Okay, hopefully these numbers are a little bit nicer. I'm pretty sure like the test questions have nice answers, so I don't know. Don't worry too much about the one that I just got. Might be like an old problem or a problem from the book or something that we grabbed. All right, so let's see the coefficient matrix. So let's solve for x. X is going to be equal to, it's the determinant of the coefficient matrix, which would be 3, -6, -1, 2. And then the same thing in the top. But we replace the x column with the solution, so -24 and 8. And then -6 and 2. Geez, these are going to be, these aren't going to be too bad, I guess. I don't know. We'll see. Okay, so -24 times 2 is -48. And then minus, and then it'd be 8 minus negatives. 8 times -6 is going to be -48 again. So that's 0 in the numerator. Let's see what we get in the denominator. So 3 times 2 is 6. And then minus, and then it'd be -1 times -6, which is a positive 6. So we get 0 over 0. So that means that these probably would give me infinitely many solutions, the way that I have it. And yeah, that's going to be the case. Why would we put that problem in there? That doesn't make any sense. But whatever. The reason that we're going to have infinitely many solutions for x and for y is because if you look closely, if I were to multiply this whole equation by -3, you know what I would get? So if I distribute it in there, -3 times -x is a positive 3x. -3 times positive 2 is a -6y. And then -3 times positive 8 is a -24. Does that look familiar? it's like the same thing as the first equation. And back when we dealt with systems of equations, what do we determine that happens when that's the case? If two equations are the same, then that means that we're going to have infinitely many solutions. So this one has infinitely many solutions. Like we could have picked two nicer Cramer's rule problems, but whatever. I'm not one to complain. Find the inverse of A for this 2 by 2. All right, those aren't that bad. It's just a simple procedure to get the inverse. A inverse is going to be equal to 1 over the determinant of A. Or let me just write it up like I usually do, determinant of A. And then times, and then it's going to be a matrix that goes like this. So if this is A and B and C and D, then the A and the D switch, and then you just negate the other ones, negative B and negative C. That'll give you the inverse. So let's do that. So let's find the determinant of this thing first. So it's going to be negative 3 times 3 is a negative 9, and then minus, and then it'd be a negative 10. So negative 9 plus 10 is 1. So it's going to be 1 over 1. And then I just, do the switching of the orientation of the letters. So D goes here, A goes here, and then negate the other ones. So positive 5 and negative 2. So 1 over 1 is 1, and 1 times all that stuff, it doesn't really affect it. This is the inverse right over here. There we go. That's the inverse matrix. Okay, solve the system using the inverse of the coefficient matrix provided. So this one should be pretty easy. The idea is this. To find the solutions, x, which is like the x, y, and z of this, it's going to be equal to A inverse times B. Okay, the B vector, these guys right over here. So this is going to be pretty easy. We just multiply them together. So we have 1, 1, negative 1, negative 3, 2, negative 1, 3, negative 3, 2. That's the inverse. And then we just multiply that times B, which is 1, 2, and 0. And this should give us x, y, and z. And the dimensions match up because this is 3 by 3. This is 3 by 1. So it's going to be a 3 by 1 matrix. We just need to do the multiplication algorithm. So the matrix on the left gets the rows, and then this is like the lone column. So I'm just going to use that. Now let's do our multiplication algorithm. So each row gets the row values. So 1 times something plus 1 times something minus 1 times something. Negative 3 times something plus 2 times something minus 1 times something. And then 3 times something minus 3 times something. And then plus 2 times something. All right, there we go. And then the column, the lone column is going to be 1, 2, 0. So I just put 1, 2, and 0 for all these. All right, let's see what we end up with. So that'll be 1 plus 2 plus 0, so 3. And then I've got negative 3 plus 4 plus 0, which would be a positive 1. And then I've got 3 minus 6 plus 0, which is negative 3. So that's the solution for x, y, and z. All right, last one, find the values of x and y that make this true. So let's see. So I'd probably multiply these two matrices together first, and then set them equal to each other basically. So let's do that. So we've got row by column, so we have to multiply first. All right, so let's see. This is going to be a 2 by 3. So 1, 2, 3, 1, 2, 3. All right, so row number 1 is 2 times something, and then minus 1 times something. So I do that across all the rows. And then x plus y and 0. So x plus y times something, and then plus 0 times something. All the way across. Okay, and then we do the columns. So the columns are 2 and negative x. And then the other column is 0, 4. And then the last column is 0, -2. All right, then if we multiply all that stuff together, here's what we get. All right, so let's see, that's 4 plus x and then let's see, 0 minus 4, so -4. And then 0 plus 2, so 2. And then 2x plus 2y. And then 0 plus 0 is 0. And then 0 plus 0 is 0. All right, and that's equal to the this matrix that we started off with over here. So y minus 4, 2, 4, 0, 0. Oh man, they didn't give us any freebies for this. That sucks. Because every now and then you'll be able to get like the x and the y value all by itself, like just right off the bat. That's not this case. So it looks like we're going to have to set, because look, the -4 is already equal, the 2 is already equal, the 0 is already equal. So that means we got to set the other stuff equal and hope that it solves. So 4 plus x equals y. And then for the other one, 2x plus 2y, 2x plus 2y equals 4. All right, let's see. How would I want to solve that? I guess I'd take the top equation and, since I've already solved for y, I'll just use substitution in here. So that gives me 2x plus 2 times y, and y is the same thing as 4 plus x. I made that look a little weird. There we go. And then that's supposed to be equal to 4 in total. Okay, and then if I distribute the 2 in there, I get 2x plus 8 plus 2x equals 4. So in other words, 4x, oops, it's a little weird, 4x equals, let's see, well, sorry, I don't want to skip a step. 4x plus 8 equals 4. Subtracting 4 from both sides, I get 4x equals -4, and that means that x is going to be equal to -1. So there's one of them, x equals -1. And then, I'd use one of the equations, probably this one, to solve for y. Y equals 4 plus x. And I just found out that x is -1. So 4 minus 1 is 3. So y is equal to 3. And that completes the extra review. All right. Honestly, as I'm looking through this stuff, I'd probably say that this will be on there somewhere. Maybe not even as like a main problem. Finding the inverse will be on there. Kramer's rule will be on there, but it won't be any of these weird ones where you'll have like infinitely many solutions or something that has like fractions as an answer. I just don't see that in a test. So, if you were really creeped out by those ones, don't worry about it. Finding the determinant, I could definitely see this one in here and also A in there because they're like pretty easy to calculate. I don't see a 3x3 being in there, but if you had a 3x3, just be patient with it and you can answer pretty easily. I could definitely see 3 as a question where it's just asking you to do a bunch of, solving. And then I can see 2 with the different computational things that are going on there. And of course, a problem where you have to do Gauss-Jordan elimination or Gaussian elimination by hand. Okay, so I guess that's about it. If you need some additional help, make sure to reach out to your teacher and get that help. So that's about it. I hope you enjoyed the videos. I hope they were helpful. And I'll make some more for the next matrix unit. All right, until then, see you later. Bye-bye.